Hello guys, very good evening. As I told you in last video that we are going to learn the electrical load calculation in MEP design. So today I am continuing the same part. In last video I have covered 3 subtopics in load calculation. Now I am starting with the fourth one, that is standard supply system in India. Many of you already know the supply system in India. What is that? Is single phase and three phase. Single phase will include 2 wires, that is phase and neutral. The voltage will be 230 volt and 50 hertz. Where in case of three phase we can find 2 types of system, that is 3 phase 3 wire and 3 phase 4 wire. 3 phase 3 wire only R, Y, B. There will be no neutral. It is useful when you need only 3 phase system, like when the equipments are only of 3 phase. But if your system is included with 3 phase as well as single phase, that time you require both. So but incomer line is 3 phase. In that case, to have single phase you use 3 phase 4 wire, so that you can use RYBN as well as RN, YN, BN. Likewise you can use. The phase voltage or the voltage between any 2 phases will be 450, whereas the voltage between phase and neutral will be 230 volt, and frequency will be 50 hertz. And when it comes to color code, RYB will be red, yellow and blue. For neutral we use black color. For earthing we use green color. Wherever you go, you please identify which line it is with the color code. Then next topic is typical connected load density. It will tell you how much wattage you have to consider for particular type of building or particular type of area. If it is residential high end, we use 4 to 5 watt per square feet. If it is just residential normal, 2 to 3 watt per square feet. Residential low end, 1 to 2 watt per square feet. IT and IT is building. There the load will be more, somewhat it will be more, that is 5 to 8 watt per square feet. And hotels also it will be 5 to 8 watt per square feet. Then school or college it is 3 to 5. Industrial light it is 5 to 7. Industrial heavy 10 to 15. This is about the load density for different types of areas. Next, diversity factor. This is the most important term we can say in electrical design, and many of you already know that what is the definition of this diversity factor. It is simply a connected load divided by demand load, right? Usually it will be more than one. Suppose, just take an example, if you load your transformer just on connected load, the loading will be more, it will be overloaded. Why? Because you will not run that load all the time, all the day, right? So you have to consider demand load on sizing the transformer or any equipment, or even cable sizing, breaker size also. You have to do it on demand load, not on the diversity factor. Okay, and I said you that it will be greater than 1. So if it is just 1, that means what? Connected load is equal to demand load, or demand load is equal to connected load. If it is 2, that is demand load is half of the connected load, that is 50%. If it is 4, it is 25%. 25%. So it will be like that. what if usually we will not represent that diversity factor in 1 2 4 like that. We usually give it in percentage, that is 0.5 0.2 0.7 like that. So it is very important that how much diversity factor you are going to apply in particular area. In residential it will be 0.5 to 0.7. Why? Because that is 50 to 70% load is is running out of total connected load. Why? Because you can see in residential homes, the from 11 to 6 all the lights will be off only. Then after 6 to 8 maximum load will run. Then 10 to 4:30 most of the people will go to office or college. So that time very less load will be there. On that basis you have to consider the diversity for other different areas. Now you can see as per MBC, for residential it is 0.5 to 0.7, for office 0.7 to 0.8, then IT or ITES it's 0.75 to 0.85, mall and retail it's also 0.575 to 0.85. For us hospital, many of you know that hospital will run all the day, all the time. So that's why the diversity factor you can say it is 0.8 to 0.9. School or college, that is also less, that is 0.6 to 0.7. Industrial, it will be little more, that is 0.8 to 0.9. But firefighting system, there is no there is no discrimination or any chance of taking risk in fire. That's why the diversity factor will always be 1, whatever the situation, whatever the condition. For HVAC it is 0.8 to 0.9. This is all about standard supply system in India, typical connected load density, diversity factor, right? In next video we can continue with the other terms, other topics. Thank you, and please do subscribe to my YouTube channel so that you will get notification on my upcoming videos. Please do subscribe, like, share, comment, and you can also comment in the comment section if you have any doubts or queries. Thank you.